Another day, another story. In the depths of space, a Stanford researcher embarks on an extraordinary mission, growing crystals on the International Space Station and developing electronics capable of withstanding the extreme conditions of Venus. Join us as we delve into this remarkable journey. Venus, often referred to as Earth's sister planet, is more like Earth's evil twin. With surface temperatures soaring to a scorching 480 degrees Celsius and atmospheric pressures 90 times that of Earth, it's a truly hellish environment. But what can we learn from Venus's history and environment to safeguard our own planet from the ravages of climate change? I'm Debbie Senesky, an associate professor at Stanford University, and we're here in the Extreme Environment Microsystems Laboratory. Our mission to create robust electronics and materials for space exploration, enabling technology to thrive on Venus. To make electronics work on Venus, we turn to wide bandgap semiconductor materials. These ceramics, like your pots and pans, endure high temperatures while reliably conducting electrons, making them ideal for sensors and communication in the Venusian environment. However, crafting electronics from these semiconductors presents its own set of challenges. We struggle with defects and understanding their function in such harsh conditions. But we're not backing down. We're also harnessing the unique environment of space to create novel materials. Chemistry behaves differently in microgravity, offering the possibility of materials with unparalleled properties. Microgravity eliminates sedimentation, paving the way for innovation. Over 2 decades ago, microgravity experiments on the space shuttle revealed materials with fewer defects and faster growth rates. Manufacturing in space can truly yield superior results. Our upcoming experiment on the International Space Station involves synthesizing graphene aerogels. Lightweight, porous, electrically conductive, and thermally insulating, these materials hold immense potential as heat shields, battery electrodes, and sensor materials, all with enhanced properties due to microgravity manufacturing. Space manufacturing is not science fiction. With the rise of commercial low Earth orbit destinations, we're on the brink of a new space economy. These platforms will enable us to create materials and technologies we could only dream of, revolutionizing the way we live in the coming decades. The future is unfolding in the vastness of space, with researchers like Debbie Senesky pushing the boundaries of science and technology. Join us on this journey as we explore the limitless possibilities of growing crystals on the International Space Station and conquering the extreme environments of Venus. Thanks for watching.